Good afternoon, everybody. Welcome back to another Free Support Friday with none other than your host, Fusion Phil, here at jitcadcam. Now, I know we did just start this meeting. We're going to give it a few minutes for a few more people to jump in here. I know we get some late arrivers. As I'm being told, too, you guys, what I see for view count on my side is pretty dramatically delayed. So if you guys could, go ahead and let me know down below in the chat. Can you hear me? Do I look good? I did trim a few pounds off my face, failed to use the razor to clean it up the rest of the way, but we'll give it a few more moments. Obviously, as you guys know, no better way to start this session than, of course, to crack open a lovely energy drink to keep my afternoon going, to which I have a feeling is going to be a very long day nonetheless. In the meantime, we do have a special treat for you guys out there. We are going to be covering a part supplied by one of our partners. So this will get interesting. This will get fun quick. So again, I'm going to give it a few more seconds. If you guys can hear me, let me know in chat. If you guys can see me all right, there's no problems. If anybody knows me, we have nothing but the best of problems on my end. So it looks like chat. Well, there we go. It came through. Awesome, Travis, we good. All right, let's jump into it. So I'm going to go ahead and swap my screen like always. If you guys are new here, I'm Fusion Phil. I'm the owner, operator, and all of the above, it seems like, at jitcadcam. We are an Autodesk reseller, and thanks to all of you with our support already, you guys help provide the funding behind the Free Support Friday for anybody and everybody. So as you guys can see, I have my Fusion pulled up. You guys can see, learn it down there in chat right now. They are the one that provided this model. They reached out. If you guys haven't checked out their YouTube channel, they're crazy good. Awesome tutorial videos. I envied the subscriber and the view count over there quite heavily, but they did reach out to us. They had a couple of questions about wanting a second opinion on how to machine out something like this stamping die or this mold cavity, right? So with that being said, I'm going to go ahead and possibly next week, I'm thinking I might do a workflow Wednesday on mold making or maybe 3D surfacing toolpaths. I don't know. You guys are going to have to let me know. But let's start with the basics, right? First and foremost, as most people do, I don't know why you guys do, there's a giant warning here about undergoing maintenance. I don't know why this message comes up. People don't read it. They close it out and then they find out real quick that, hey, I can't use Fusion, and it's because you never read the warning when there's going to be a problem. Oh man, here we go. Learn it already in the chat with $14 Canadian. Let's go. So as you guys can see, we're going to go ahead and switch over to the manufacturer workspace. We're going to create a simple setup here. Now, in my case, very rarely do I ever use relative size box. If you guys have ever taken my training or I've ever talked to you, you guys know why. Again, I like nominal material. In this case, I'm going to set it to 0 to limit how much my roughing cycle really goes around the outside of the part. So from here, now the first question that was asked was roughing this part out. Now, prospectively, I have yet to pull a measurement on this to know whether or not this part is 1 inch big or possibly 10 inch big. So I'm going to go ahead and pull an inspection off one of the lines here. We're looking at about 10 inches long. In this case, it's more like the second thing I said, which was about a 14-inch long part. Now, on something of this size, we could very easily be fighting things like using a 1/2 inch end mill is inefficient. Maybe our machine doesn't have torque to go bigger. I'm going to approach this multiple ways and figure out what is the best. So the great thing about Fusion is the ability to actually grab any toolpath. And as all you guys know out there is we go ahead and hit the OK button so that the software prompts us on what exactly it wants. So as you guys can see here is I'm going to go ahead and go to my default library. Actually, I think I have my VF2 with my favorite tool, 1/2 inch cutter. Now this is a long stick out tool. And by default, Fusion is utilizing the speeds, the feeds, the step down, step over from the tool library. Now, while that's happening, I might circle back and try a pocket clearing as well. Now, something that could get me in trouble here is rest machining right off the start. Now, I am comparing strategies. So my goal is to turn off rest machining. Again, we're going to go ahead and use that same tool as you guys have seen. I'm going to go ahead and define maybe a little bit different set of parameters. Or, as you all know me quite well, we just go ahead and hit OK and see what we get. Now, as you can see, in the roughing strategy that we have here, Yes, we are machining down this end. We're going to ignore that, but we are roughing out our part, right? That was our goal, is to rough out the part. Now, did we achieve that? Yes, we achieved that quite well. Now, where I may make a difference in decisions is upon running something like this toolpath, and we'll simulate this, is this toolpath with adaptive clearing is going to go as deep as it can and then utilize only a portion of step over. So I like to say it's going to use the flutes of the end mill. Why that would differ from pocket clearing is always stepping down in Z, right? So adaptive clearing is going to go way down and work its way back up. Pocket clearing is going to constantly step down. Now, having a background in mold making and dealing with female cavities or a negative cavity, as you guys can see, we're working in a bathtub, right? Chip evacuation is going to be key here. So hopefully, learn it over there, whoever he's setting up or training on this part, they have a horizontal machine where we don't worry about chips, or vice versa, they have a 5-axis, mounted this on the table to tilt it over and dump out the chips midway through. But let's take a look at the two strategies, right? So again, we're going to go ahead and simulate this toolpath. As you guys are going to see, again, what we're working with right now is going to a maximum depth of cut. And again, engaging only a percentage of step over. Now let's go ahead and turn this on and let it crank up so that we can get through this part a little quicker. And again, once we get down to this end, you guys are going to see this is where we start to work back upwards around the part. So again, you're seeing what I like to say the staircase effect as we go upwards, utilizing things like our minimum step downs, flat area detections, things like that, right? So from this, let's take a look at our pocket clearing toolpath. So as you can see, we have pocket clearing here. I should get used to using my shortcut keys, of course. So again, if you guys didn't know, the S key shortcut menu, you can customize to whatever you want. Now, what we're going to see here is because our stock is already removed, we're not going to see the same kind of toolpath being machined out. So let's go back and fix this. So I'm going to go ahead and drag this back to the top. As you're going to see now, when we simulate this toolpath, we are going to get a much more straight line and linear path. And again, for those of you that don't know, usually we can really ramp up our feed rate here, right? So now I don't think one is right or wrong. There's a use case for both. They're both going to give you adequate results. What we're really looking for at the end of the day, if I get way down inside this cavity, and we're going to go ahead and make that transparent. What I'm concerned about as we're getting into other things here is the ability to pay attention to these small fillets on the inside, right? So we are lucking out with something like a 1/2-inch tool. Now, you may not be able to get an insert mill or a high feed mill in 1/2-inch. You may have to go up in size. Again, that is going to cause a problem in these small little fillet areas, right? So again, once we utilize a larger tool, I'm going to go ahead and delete the adaptive clearing. We may want to go back and utilize, again, a second tool path with a smaller tool. Now, in this case, Learnit's going to have to let me know out there in chat whether or not he's doing this on a 5-axis or if we are in a full 3-axis. But let's go ahead and step down to our 1/4-inch cutter. And from there, we are going to make sure that we have rest machining turned on. And now this is a key element here, and you guys are going to see this, is this ignore stock less than is going to be a great friend here in a second. So good high feed mills. Travis with some recommendations. Bogdan, great to see you out there. I don't think, Bogdan, did you make it here last week? You were right at the tail end, weren't you? So continuing on, we're going to go ahead and we're going to use rest machining. Currently our ignore stock less than 8 thou. We're going to see what this does right off the start. Learnit's also going to have to let us know what kind of material we're working with, because that's going to make a huge difference as well. Oh, you were here. Awesome. So as you guys can see, rest machining right now, all we want is really to worry about the fillet in the corner. We don't want to worry about this big surface area out here. We've basically roughed that out. So this is the advantage to being able to say something like ignore stock less than, let's say 25 thou, right? So by increasing that number, we should naturally trim down our tool path and start to remove some of the areas where that is happening. Now, keep in mind, because of our step down being difference between the tools, that is what we're starting to have an issue with, right? So something I want to show you guys real quick is if I was to sketch something here, and let's just say examples, I like the good old fashioned rectangle, as you guys can imagine. And then let's say, for example, our surface is kind of like a spline, right? So that ignore stock less than situation, the reason why it's also still picking up on those step downs is because if you think ignore stock less than said distance, right? So normally we're doing a stock to leave here of 20 and a stock to leave here of 20, but now the distance here is what could be actually much larger than 20 at the end of the day, right? So what this would really look like, and I'm going to shrink this in a little bit so you guys can see this, it would be more of a rectangular profile. And again, based on your math back in the day, of course, this point here should have actually ended up on our curve. This point here should have ended up on our curve, right? And if this swerf, or not swerf, I apologize, our spline, the distance of this leg is what's still going to have to be calculated for. Now, I did see some cool tricks out there, and I've seen a lot of people say that if you are to adjust things like your tolerance, also things like upping your smoothing can help remedy this. So material is M2. Of course it is. It's nothing but a good time, right? So again, what we're really looking for roughing wise, again, big cutter, moving into our smalling cutters, but let's go ahead and get down to the meat and potatoes, which I think is what Learn It is after. So let's start to do our 3D toolpaths. Now, given our profiles here, I'm more than certain that there is, of course, always going to be taper on these walls. So the idea of being able to do a radius cutter nice and easy across the top is just not going to happen, right? So this is where I may pivot, and this is just me. I personally would go for a steep and shallow toolpath, or I might go for a geodesic toolpath. Now, big difference between the two of them is geodesic is aimed more at a shallow area. And the reason why I say that is when we look at our actual passes tab, you have what's called step over, right? So when a toolpath has step over, that's when we tend to see, you know, it's more of a shallow area strategy. So if I was to use geodesic in this area right here, again, we're going to go ahead and swap our cutter out to a ball end mill. So let me go into my lovely repertoire of tools, good old fashioned 1/2 inch ball. And again, as you guys are seeing, this is being driven by a surface. And with that surface, we're going to go ahead and hit OK. Now, we may have to go back and make a couple of adjustments, of course. But as you're seeing, this is following the outer profile of everything we have inside this area, right? So again, that's the luxury of something like a geodesic toolpath. However, if we did the same thing instead using steep and shallow, now what I'm going to do is I am going to do a selected boundary, of course. And what we want is we only want to go around the top outer edge of our part profile. Now, for some of you out there, you're noticing that I still use the traditional method of selecting a chain and creating a closed chain loop. You could have easily done this with face contours, giving the limitation of surfaces. So again, the nice thing is as you guys can see, I can go through and pick all these faces. Now you're going to notice I can't pick this vertical wall, which could lead into some other problems outside of that. So again, I'm going to stick with the closed chain method, tool center, contact point boundary in case we need to shift a little bit, getting on top of these fillets, of course. And then in our passes tab, you're going to notice this is one of the few tool paths that have step down in combination with step over. So again, let's go ahead and say we're going to do some 50 thou on the walls, and I'm going to come back with some 0.25 on the floors. And with that, let's see what we get. So again, we'll give that a few seconds to calculate. And as you can see, because of the transition between strategies, up here in my shallow, I'm scalloping right now. Getting into my steep area, I'm kind of doing a contour. And then again, transitioning back to a scallop strategy. Now, if the surface finish was a big deal, this is where I may change my technique a little bit here. So this is where I would go in and I would say edit. Maybe we would actually get some stock to leave on here. I'm going to go ahead and leave 10 on the walls, 10 on the floors. Maybe we up our actual amount of step over and step down. So again, let's go up to like 60 and 40. Now what I'm doing is I'm pre-finishing everything in there to more or less remove all these step downs and these scallops, right? So again, is I can use steep and shallow as a pre-finish strategy. I could very quickly now duplicate this tool path. For those of you wondering, I just push Control D as in Delta on my keyboard. Go back to whatever we were planning to do. Maybe it's 30 and 20 or whatever your situation was. Turn off, of course, stock to leave, as I failed to just do. So let's go back and get stock to leave turned off. And as you can see, this would probably be more than acceptable. Now, again, there's a lot of different things we could do with this, right? For example, this is a parallel, or not a parallel toolpath, it's a scallop toolpath. So we are going from cutting the length of our part to up cutting and down cutting in certain areas. By switching out from the scallop toolpath, we could go ahead and say parallel instead. And as you guys are going to see, is that parallel toolpath now runs either the length or the width of our part, right? So again, as it's actually transitioning from one to the other. Let's get those linking moves out of the way so that we can see this a little better. So as you guys can see up here at the top, it's running the length of the part to help blend that fillet a little better. Now down here on the surface, we're actually running left and right or across our part. Now we could control this at any time as well, and we could force a fixed angle. Same as anytime you're using parallel by itself. Again, we could simply say fixed angle, pick a direction, make everything run that same way. Now, as you guys are guessing and seeing here, is it's pretty straightforward on a part like this. It's nothing too crazy or too fancy to go in and surface finish mill this. Now, if I really wanted to get into more nitty gritty stuff, this is up to you all, but we could now start to talk about things like, what if we use blend, for example, and I want to blend my upper two areas and I need drive curves, which, guys, I always forget which way I need these drive curves to go, so bear with me. And with that, what are we getting? Are we going up the part or down the part? That's why you're seeing me just apply very simple things, and now I'm getting a warning. So let's go ahead and go back and fix this. Sometimes it's easier, even as an expert. Let's start with one. Let's go ahead and see what it tells us about what we need. So no curve selected to machine. We're going to need one or more drive curves. In this case, we don't want that curve there. We're going to go ahead and hold the Alt key, extend this guy out just a little bit, and let's see what that gets us. So again, if it's not a normal Friday, we'll get a toolpath this time around. And as you guys can see with that blend strategy, what's happening down here at the end, if you remember that little tail end of this toolpath, right? It is following that tail, which means it's coming down here and blending and staying based on that rail with our toolpath. So again, that's another strategy you could be using up there to clean up just the upper outer fillets on a part, right? So as you can see, blend, great for external fillets. Now, when we start to talk about internal fillets, this is where we could use something like the corner strategy. Now, the corner strategy, again, this is like at the end of the day, guys, you're probably seeing a lot of toolpaths some of you may or may not have ever used. You do have a free 2-week trial of the machining extension. The only thing I ask of all of you is to reach out to yours truly here to utilize and get signed up and get that purchase to get it added to your license, because all these 3D techniques I'm using, one, they're a million times more powerful and much easier to use, which saves me time. And I'm a big fan of, if I could save about an hour a week for the next year, this thing's going to pay for itself. But it's just that at the end of the day, these toolpaths are much more powerful. They're much more use case specific. So as you guys are seeing me do, only internal fillets, right? So again, as I have a steep and shallow strategy once again. Now, the big part about this, what I like, is the fact that the rust machining here is unlike anything else. Now, I wish they would roll out possibly rust machining like this all across Fusion. But as you guys are seeing here, is I can go out and pick a tool that I want to utilize. And now, since the latest update inside of Fusion, as you guys can see, is I can actually do that from the drop down. So what we're going to do is we're going to grab that 1/2-inch ball for rust machining. I failed to give this, in this case, a smaller ball end mill. So let's go grab one real quick. And with that, let's go ahead and see what we get for a toolpath. In the meantime, if any of you guys out there have any questions, I, of course, am here to answer those questions. Now, I know it gets a little quiet in chat because most people just are trying to take in the craziness of what I'm doing or how I'm doing it. But give this a few more seconds. Now, I probably broke the #1 rule that I tell most people is you don't need your tolerance set all the way down to 4/10. If we bump that up to 4 thou, it's going to give us a much quicker calculation. Then we could go back and change our tolerance so that we get a much slower, or not a slower, but a much more precise toolpath at the end of the day. So again, As you guys are seeing, again, we're ignoring this funkiness on the outside of this part, of course. But as you can see, that corner toolpath is aimed specifically at rest machining based on what a 1/2-inch ball end mill would have done in those areas, right? So again, I don't know, Ty over at Learn It, you're going to have to let me know in chat, man. Is this up what you were thinking, what you were looking for? I do see it, loving it over here. Great job. I appreciate it. So again, it could be in the case of a part like this, we are talking about M2 material. So we may want to do something like a steep and shallow pre-finish. And this is something that always cracks me up because I see a lot of people do this is we can relabel these at any time, right? So I could say O2 stock to leave pre-finish. Some other things that you could do inside of here, which is always fun, is a lot of people don't realize that you could also edit and add notes to this. So if I wanted to, let's do a change tool after cycle. And in this case, maybe we're using a 1/2-inch ball twice. It's M2. Maybe it's going to eat this tool up when we go through there and bury everything. And then later, try to reuse it for whatever finishing strategy we're shooting for, right? But with that, you can post this out. And the neat thing is when we post this, depending on what post you use, of course, you do usually have to turn on the show notes button. So if you all give me a second to go ahead and find it here, but let's go ahead and do our show notes checkbox and let's post this G code out. And as you guys are seeing, is we've very simply stuck in not only the name of the operation, but the notes about changing the tool after the cycle. Again, we can start to do a lot more fun stuff with this. So that kind of concludes the first question of the day. I know we're in this, 20 minutes now? I took 20 minutes to start to apply toolpaths quite heavily to a part like this. I'm going to open this up to you guys if you guys have any questions, or I might pivot now and maybe swap out the 3-axis for a 5-axis situation. You guys let me know in chat real quick. I know I get tons of questions about how hard is 5-axis, and honestly, I feel like it's much easier at the end of the day. I'm also going to check here real quick. I got to pull it up on my other screen, of course. Just want to make sure I don't have anything crazy coming in. All right. Yep. So in this case, I cannot share what that question is for one of my customers putting in a support ticket right now, but it would have been cool. It's pretty neat stuff what they do over there. So as you guys are going to see, let's go ahead and shift gears, right? So this is kind of the fun inside of Fusion is, again, once you get a toolpath based on what you want in a 3-axis environment, this is actually a really good kind of situation where if you guys didn't know, and I might be able to pull up a picture of this. Let me see if I can get something easy for you guys. All right, here's a good example. Let me get this moved over onto my other screen. So, shout out to whoever's website this is. You guys can see this, I hope, right? So, one thing a lot of people don't realize is on the tip of your end mill, in this case, if you notice, although this is a 3-flute end mill, there is only 1 flute going to center, right? So realistically speaking, when we're cutting on the tip of this tool out to said angle, right? Anything outside of that is going to be considered 3 flutes. However, anything inside this center diameter, and I say angle because it is technically, these reliefs are at a specific angle. The problem is at the end of the day, you're still only cutting with 1 flute. So if you're suffering from really bad surface finish in shallow areas of your part, this is usually the culprit. Now, if we were to go back and look at a completely different tool, all of your flat end mills, if you're using a 4-flute, usually you only have 1, if not 2 flutes to center. So again, this is something to take into account. And this is why a lot of the industry transitions into like a 5-axis type of toolpath. Because when I get down here in the shallow area of this part, I'm going to be cutting on the tip of the tool. Now, I've seen this before because you're running at a feed rate of 3 flutes, but you're only cutting with one flute, which leads you into problems down here, also around the very top fillets for the blending on that part. So we could, in theory, you could actually split your toolpath up. You could use slope for this. Let's say 5 degrees. The first 5 degrees on the tip of that tool is the problem. So we will not machine anywhere within 5 to 90, right? Well, I take that back. I'm backwards there. We're only going to machine between 5 and 90. So again, we're now avoiding upper areas in this lower little section. However, if we had a 5-axis machine, this is where we could completely change the way we do stuff, right? So again, instead of using slope, what I'm going to do here is I am going to have to swap out my tool. Let me see if I have a ball end mill. I do have a long reach ball end mill. Awesome. So it's going to be a little tight here, but the idea is now based on multi-axis. Again, we can go to full 5-axis, multi-axis, or Ty, in your case over there at Learn It, you might actually have a 4th axis, which might work just as well. And with that, we can do our setup based on whatever direction our X is. Again, we're now going to tilt with a live 4th axis machine. Again, do I want the tool to point at the rotary axis? From curve to curve. There's a lot of settings here for you guys to be able to go through and manipulate. But again, let's just go 5-axis to start. We're going to leave it as basic as possible. Now, what's going to happen is it's going to stay 3-axis in this case until it gets to a certain point where it needs to tilt the tool to one side or the other. So let's go ahead and simulate this so that we can see when those tilting moves start to take effect, right? So again, we're going to go ahead and hit play. As you guys are seeing, it's running up and down the length of my part because this is a parallel tool path. Now we've transitioned into our scallop, or actually our contour portion of steep and shallow. And as we work our way down, eventually, if the software doesn't make me a liar, which is pretty good at, right? So as you guys are seeing, we're starting to hit our tool holder. Does anybody know why we were hitting that tool holder? Because I know why right off the first part, right? The whole concept of that is based on the fact that we never turned on anything like our collision avoidance, automatic collision avoidance, things like this, right? So again, by putting on automatic collision avoidance, we're now going to tilt that tool automatically. As you're going to see, we are trimming where we can't technically reach with this tool. So again, we're going to go ahead and simulate. Let's go ahead and hit play again. And in this case, we're going to let this speed up a little bit because at some point we're going to start to see tilting of that tool. So again, as you guys are seeing now, when we come through here, the tool is fully tilted and we are using a full 5-axis tilt to be able to come around the edge of that part. And again, we're not cutting on that tip of that tool as well. If we go back and we actually change things up a little bit here, we can actually get it so that all of this surface is actually being a 5-axis toolpath. So again, if we go back into that toolpath, as you guys are going to notice here is I'm only changing things from a top to bottom approach. So again, primary tool axis, maybe I want to do a lean. I could actually set a lean angle. Maybe it is 10 degrees. I always forget, is that from vertical or is that from horizontal? As you guys can see, it's from perpendicular of the tooltip, right? So a 10-degree lean should, in theory, only tilt me to like a 2 o'clock or a 3 o'clock position. So let's go ahead and turn off collision avoidance here real quick. And we'll let this go again. So as you guys can see, we're getting a lot more trimming. My tool is now starting at a tilted angle. Again, we could put collision avoidance back on and a lot of that fun stuff to get a little better tool path. But what I'm looking for is a way to get you guys set up. Again, this parallel tool path is kind of screwing us when it comes to doing this first little segment, right? And that's what's happening is you're seeing that it's trying to maintain a 10-degree tilt from that surface. And if I can get you guys lined up here, because perpendicular to the surface would be out this way. We're a little bit more to the right, meaning we're no longer machining on the tip of our tool. And again, we are preventing a surface defect based on that 1 flute scenario versus 3 flutes. Cool. Do you guys have any other questions outside of that for this mold procedure or anything I'm doing inside of here? Feel free to throw them in chat at any time if you do. Again, we could actually set preferred tilt angles and other stuff outside of that as well. So maybe I will make a fancy 5-axis class and we could talk about that more. Now, keep in mind, we do also have one more toolpath that we're going to talk about multi-axis, which is multi-axis finishing. So I don't know if Ty has access to a 5-axis, but if we were to use multi-axis finishing, this is where some real power comes into Fusion as well. Again, utilizing our ball end mill, or in this case, this is one of the only toolpaths right now that allow you to use something like a circle segment cutter or a barrel cutter inside of Fusion. And the idea is when you're doing those walls, if we can get a bigger radius on those walls, and showing this to you, oh, I'm in the wrong one. Let's go back. We're going to go ahead and add a circle segment oval. What's happening is there is a very large radius right around this edge of the tool, right? So again, this radius is much bigger. As you can see right now, it's 3.75 versus a 0.25 that is for a ball end mill. So again, way better surface finishes. If you've ever looked at somebody doing something like a turbine impeller, things of that nature, that actual barrel cutter or your circle segment ovals, night and day different surface finishes, right? Cool. Any other questions from any of you guys out there? This is your time to ask questions. If you guys want to provide us with anything, feel free to. I'm here for you guys. I'm here to answer any of your questions, help you guys with anything you may have going on. As you can see in this case, the problems, or not problems, I shouldn't say problems, just a second look at what we were doing. This is what we do over here at jitcadcam. And so you guys know is we do have a buy me a beer program if you did find something useful. As you saw Ty out there from Learn It, bought me a steak is what I would chalk that up to. But outside of that is we do what we call generic consulting under our service plans. And what that allows us to do is for you guys to send us your part files or for us to sit down and review them, as you guys saw right here, and go through a couple of different scenarios of what we do and what you might do to be able to streamline your workflow or save time to be able to do it. How can we ensure the cutting quality? So that's going to be a little tricky. Now, from a surface quality standpoint, as you may be seeing here on my part, is I do have graphics wise visually where I have and where I haven't machined, which would show me surface defects based on the tool path. Now, the real problem is it's hard to say is as I'm pointing out with that 3 flute end mill, as Shervin's asking, is without knowing that only one flute goes to center, you could be chasing your tail until the end of the time, especially in a 3-axis environment, as we saw earlier, right? So again, is if I was going to say, first and foremost, based on an angle, again, let's say we're going to use 10 degrees this time. But if I was to run my part right now, 3-axis ball end mill, but I have some really weird surface stuff happening basically right here and up here at the top, odds are it might be my cutter more than it is the tool path itself. Of course, right now, if I ran this exact program, this is an example for you guys, but the idea would be is why is there a surface defect down there, right? Now, a few things that Fusion does have to help you guys from a surface finish standpoint is you do have the ability to calculate things based on cusp height. Now, a lot of people have asked me about cusp height. Well, the idea of the cusp height is, as you can see, they're kind of stepping down a 45-degree wall. There's a lot of really good calculators out there to determine surface finish from cusp height and tool nose radius, right? So that's what I usually recommend for people is, what is it that you're trying to accomplish, right? Now, if I pull this up on my other screen here real quick, let me see if I can find one. Got to remember. So one that I've seen that works quite well is, let me close out all these lovely cookies. Kennametals does have a pretty good calculator at the end of the day. So again, they're doing one based on corner radius and things of that nature. Now, keep in mind, what you're really going to want to look for is one that is based on like a ball end mill. So that would be one thing to keep in mind as well, or else you're going to end up with kind of the specs of a lathe, right? So again, Kennametal's ball nose surface finish versus the normal surface finish. As you can see, we could put in our ball nose radius. I'm using a 1/2 inch cutter, so that's a 250 radius. Let's just say it's a 35-degree helix. The rake angle isn't going to matter. But as you can see, we could actually base this all on step over, as well as your feed rate does play a factor in this. So if we were doing a 20 thou step over, it's going to give me a surface finish of 45. So could I up that to 40? That's a 181 surface finish, right? So this is all stuff you have to take into account because, again, as you're going to see, as we have inches per tooth. Again, if I'm working with a, let's say 2 thou inch per tooth, 3 flutes, again, that's a 4 surface finish, and that's based on just my feed rate. But I would need to roll up my feed rate plus my step over to make sure that I get the proper actual surface finish or get a cusp height that is going to work specifically for my surface finish, right? So again, a lot of different ways out there for you guys to go through. Again, calculate anything and everything so that you can find what is the proper cusp height, what is the cusp height going to translate to when it comes to surface finish, and plug that information in. Let me go ahead and get everything shifted around. Let me go make sure nobody's put in any support tickets. Nope. So with that, do you guys have any other questions outside of that? Shervin, I hope that helps explain it a little bit more for you. 5-axis machining courses. So we host a lot of custom 5-axis type of content as well as one-on-one trainings. The real problem I would say is there's not really a one-fits-all type of scenario. So a lot of times a customer comes to me and they may be doing impellers, which we can do impellers in Fusion, and we have to evaluate, is Fusion the best choice there, or is it something like Power Mill that they should be moved to? But that is something where we're getting into a niche workflow to be able to streamline that process, right? Now, keep in mind, we have done videos on our YouTube channels explaining things like, for example, the to and the from curve type of scenarios, how to manipulate that a little bit more. Now, I would tell you, if you want to dive into something very specific in a full 5-axis workflow, feel free to shoot us an email, and that info@email down below, we can get you set up with something at any time. Cool. Any other questions outside of that? Again, the whole goal of this is to open it up to you guys. If anybody has any questions, wants to see anything in particular, I know it's the last Friday of the month, which is why I'm chalking it up to the fact that odds are a lot of people are still trying to get stuff out the door, right? Let me go ahead and check a few other places here. And I am going to jump back here. So no questions, huh? I know we're a little light on the old view count this week. I'm blaming that 100% on a 4-day work week, as well as the fact that a lot of you guys went out and actually had to, I'm just realizing I had my camera on the wrong thing. Did you guys not see my screen? Was I talking and did I have something pulled up? Shervin, you're going to have to let me know. I think you're the only guy out there. Was I talking about ball nose and surface finish and everything and failed to have my screen shared? Any other questions outside of that? So I encountered kind of an interesting problem earlier personally. Not that it's Learnit's fault, but I opened up a file from Learnit and I was messing around with it. This is an assembly file that he provided. As you guys can see, this is actually a punch and stamp die kind of setup. So again, they have this lovely sheet metal part that they are forming. So again, you have your base plate, you have your top plate, all set up inside of Fusion 360 for manufacturing, of course. Now, with that being said, there's actually even a finished part in there. That's nice. So as you can see, that is the end goal for the formed profile. Now, I was getting a really weird warning about performance issues, which had me laughing because it was 5 minutes before I came into this meeting. So that is a big thing that I think a lot of people have started to encounter. And as you can imagine, I don't have the latest and greatest computer everywhere, but I still have a pretty decent computer and it was having me troubleshoot. But it looks like that problem is gone now. So I don't know what was going on with that. That was a little wild. Let's investigate this a little bit. I think I was trying. Trying a few things here. Yeah, doesn't look like I'm getting that warning anymore, but cool. Any other questions, guys? I'm opening this all up to you. I feel this is your guys' time to ask the questions you may have, different things you may have wanted to see in Fusion. We can answer anything from post-processor questions, again, different things inside of your settings, anything and everything. This is probably one of my favorite things that I've seen so far since the update is the fact that you could switch from performance to quality. And it's a night and day different experience inside of Fusion 360. It's so crazy to me to think about this as I work through this. And it looks like they actually did fix the performance viewing. That is nice. So when you go to quality view, before we were getting some really weird stuff with the material. Now, if I simulate this, I wonder if it's still going to bug it out or not. Nope. Still looks very good at the end of the day. I'm going to crank my accuracy up here and see how great we could see this surface finish. So as you guys can see again, something like this part, we do have our 3D surfacing coming through. We are getting scallop heights as we're coming down around that surface. Again, one thing you're going to notice here is this is very wavy around my part. This is where, because I have my tolerance turned way up on my toolpath, that would smooth out this type of profile information. Awesome. Well, I guess if we don't have any other questions, I'm going to get to call this one short this week at only 40 minutes versus going the full hour to 2 hours. Oh, we got a few more people that just jumped in. I'm happy to answer anything and everything, as you guys can imagine. I don't know how fast that updates for current viewers. Again, guys, we are just playing around with this mold cavity provided by LearnIt. You know what? Let's go ahead and fix the end of this part profile that we keep getting all kinds of craziness from. So we're going to go ahead and set a boundary to silhouette. And with that, we can go ahead and, let's leave contact point boundary off. We just need to be tool on center. That should get us narrowed down to being only inside there. There we go. Now we're trimmed off at the end of our part. Everything's looking good there. We do need to fix that 5-axis toolpath. Let's get that guy pulled out of there. Again, if we were to switch, let's go ahead and do a parallel non-fixed direction, and we are going to go both ways. Also see what kind of strategy we get here. So again, this is the only problem with the parallel, in my opinion, is I wish there was an easier way to do it along. Like, we could set a direction, but it's not going to agree with the direction based on each individual area, right? So if I go fixed direction, and with that, we're going to go ahead and try to reference. We can't do a curved edge, of course, with parallel. Again, the idea is that it runs parallel, but that would be something that would be nice because we are kind of partially getting up here at the top the idea that it could follow or blend. It would be nice to see blend in here along with the other, right? So again, as if we have our blend strategy and the blend strategy is working great for that top radius, why not a toolpath that kind of does all 3 or 4, or a way to merge toolpaths? I think that would be the neatest way to go about this, is where we could take like 3 or 4 different toolpaths for a couple of different areas, right? And then merge these guys together, all 3, so that it's constantly transitioning from one to the other as it machines down our part. So again, I'm going to go back into geodesic because I feel like at some point there is, so there is in geodesic, there's also blend. As you guys saw, I had blend before. I just did a normal blend toolpath. Again, we have the ability to set, how is our offsets going to work, things of that. So again, let's see what we get with this blend now based on our machine boundary. Easier cutting techniques. Shervin, what is it that you're trying to cut, or what is it that you need to cut that you need an easier technique? Just asking. I'll give you a second there to answer. You're using my way. It's so hard. Shervin, can you give me a little more information on what it is that you're trying to specifically do, and I can take a look? What toolpath is it specifically you're using, and what kind of feature are you trying to use it on? Again, any other takes a lot of time. Yeah, so that is a true statement. It does take time. The problem is because on a lot of more advanced surfaces and stuff, is it a calculation time or is it a user time, right? So as you're seeing on my end, I'm trying to add more things in here. I'm getting a lot of like mixed results. I'm going back and changing things as I go, all of that stuff. But a lot of times if you're having a calculation problem, one, you might be on an older computer or you're trying to give the software to do too much. This is where, as I showed before, is I went ahead and changed my tolerance to 4th thou instead of 4/10, and I get almost an instantaneous kind of toolpath, right? So again, little different strategy, a little different way to go about it to be able to go in and quickly generate my toolpath with the time to go back and add more to it to make it much cleaner. Reduce the cycle time or the calculation time is what you're asking. For all of you joining us right now, feel free at any time. If you guys have any questions, go ahead and throw them in chat. We are here for you guys to help you out on yet again another fantastic Friday here. I know up here in North Dakota, I think it's starting to get up into the 80s today. Possible to reduce the time. Cycle time. So at the end of the day, you're always going to find a threshold of what it's going to take. Now, keep in mind, when I was talking about doing things with 5-axis and stuff earlier in this meeting, how fast I can feed an end mill and still get the surface finish I want, that is kind of a fixed thing. Once you find that, now, some of you out there may argue with me, but let's say, for example, the threshold on this specific ball end mill, I'm only going to be able to run it at, I don't know, 8,000 RPMs and maybe 55 inches per minute, right? Now, that is something that won't change. Now, getting into something like my step downs and step overs, I could, yes, make the part faster, but the problem is going to be, is the surface finish going to be better? That's a big thing to keep in mind at the end of the day, is when you really come down to it, is even though I can feed the end mill faster, am I still getting a good surface finish as I go across the part? Now, I say that because if you see this little waffling effect that's happening in the background, right behind my head. So think about that end mill, right? It's basically scooping the material out. This is a good representation that if I feed too fast, I'm going to get scoop marks in that line, right? Now, if I'm slow that down, I'm not going to get those scallops based on my feed rate, but I may still get scalloping based on my actual step downs across my part. And again, you're seeing that up here at the top if I get my toolpath turned off. So every time that ball end mill right now is stepping, it's leaving what would be referred to as a cusp on my part. So again, this is going to be a little tricky to see. I'm going to try to get you guys the best view of this possible. But again, the idea is that ball end mill, because you have a round tool against a round surface, is never going to make a perfect fillet, right? That's why we have to increase our step downs or step overs. Stuart, great to see you come back from the UK. 3D milling does really messy leads. Plus or minus the boundary, negative offset. Have I encountered this? Yes, I've seen this a lot, and there's a million ways to trick the system, right? So we actually saw something like that earlier when we were looking at doing the corner toolpath. I was having what was called a waterfalling effect due to a bad boundary. And I'm still technically getting it up here because we're working with a silhouette of that boundary. Now, for some of you that do know and some of you that don't know, there's a lot of ways to remedy it. And as he is already pointing out, is if we're using a selected boundary, you have what's called additional offsets to go further out, further in, a lot of things at the end of the day. Now, again, kind of a pro tip that I heard from somebody is if you change your additional offset to also match whatever your tolerance is, that has a tendency to help as well from a start point, right? Because if you think about it, the tolerance of the toolpath is how close we are following the model. Now, if my boundary hypothetically is exact, but I have a 4th thou buffer of tolerance, then I may want to give that additional offset and a 4th thou comp, whether it be inside or offside, positive or negative. Now, working on a part like this in particular, as you can see, I'm starting right here on the exact end of my part. Now, this is something you may or may not want to do, and this might be a little bit more of what Stuart's referring to. This is where in the past, what I have done is gone back to manufacture, actually back to design, and I have to create my own surfaces to drive my toolpath. So one of the most valuable tools under surface is called offset. If I go to that part profile and I click, and as you're going to see is one, if I turn off chaining, I can actually individually pick all of these surfaces. Makes it a little bit more painful. Not a big deal though. As you can see, I'm still missing one more down here at this end. But what I'm looking to do is basically create a replacement skin, right? So if I look under my bodies tab right now, I now have that offset skin at 0. Now, this is where I could use surface tools to do things like extend the end of this a little bit. As you can see, I'm extending this end by 20. And let's go down to our other end and see if we can extend the other end just a little bit as well. So let's get this guy pulled out, another 150. And we might do that one more time on this lip here. So the goal right now, as you're seeing me do, is I'm manipulating that profile so that I can utilize that new piece of skin in there as what my toolpath will follow, right? So again, as if I go back to manufacturer, and we have tons of really good videos on this, but if we start to talk about, here's my corner toolpath, I don't like it starting right there on my part, right? Right where that square edge is supposed to be. I can now go into model, add an additional model. And what model I'm going to add, of course, is now that skin. So let's go ahead and click that. Now I am going to turn it off after I've clicked it so that you guys can see it's not going to sit there in the way. But this is where, again, I have the ability to control my geometry. I may want to say no boundary or a selected boundary. Again, utilizing that skin, I could possibly use the outside of that as what I want to control my toolpath with, as you guys are seeing. So again, let's go ahead and make sure we are picked all the way up and around. And just like that, you guys can see that is my now surface that I'm going to stay inside of, or my chain I'm going to stay inside of. And give her a few more seconds. Now you're seeing that we're starting that 3D surfacing off my part and working into it. Again, What I'm doing is I'm faking out the software by utilizing a surface that I created and extended said surface past my part, right? Is it worth setting it as a default, Stuart? It's hard to say on my end. I am a big fan of, if you only do it half the time, is it worth it? Because the other half of the time you have to change it anyways. But if it's something you're doing all the time, it may be worth doing it on your end. Now, something to keep in mind, if you are looking to do something like that, again, if anybody new here is jumping in, feel free to ask questions in chat at any time. But what we're talking about is how to utilize tolerance in combination with something like additional offset for your toolpath to kind of remove weird linking and lead in moves. Now, keep in mind, you can, in your case there, Stuart, is set up your expressions, but instead of utilizing, in this case, it's pulling the stock to leave. And this is why this is so important. This is so funny to me, like why people come to us with their problems is by default, that additional offset is actually pulled from stock to leave. So if I turned on stock to leave and I come back, as you can see, the additional offset is now there, right? Now, again, this is just me. I would probably rather reference it to the tolerance, right? So again, I can go to that same exact area, edit the expression, and instead of using stock to leave, I could say tolerance. Again, you could pull the tolerance from the manufacturing area. And as you can see now, whatever my tolerance is, so if we go back to 4/10, again, I go back to the geometry, it's automatically updated to follow suit. So again, there's a lot of different ways you guys can do this and set this up. So you could even say tolerance plus stock to leave. And now that might be something that you would set as a preference, right? So again, we turn on stock to leave of 4. Our tolerance is 4/10. Boom, 44. Automatic combination of the both edited. Some things can only be changed in combine and edit. That is true. So they're not combine and edit, but you're talking about combine and edit. Real quick. Oh, I know what you're compare and edit is what you're referring to. Yes. So again, there is a lot of secret things in the background that can be changed. For example, anything with triangulation, as you guys can see, there is a surface triangulation tolerance, force module works triangulation. There's a lot of secret things that are hidden inside the software, but you're really starting to get down deep in the weeds on stuff that we did do a couple of videos about this to help out. But again, unless you really need to go this deep to change things up and edit those things, there's not really a reason to veer off course from what you saw there. Elijah, great to see you here. I see that you made it. At the bottom of some stainless 304 round stock, 1-inch deep blind, I'm going to use a tap, and I was thinking of peck tapping and using through spindle coolant. How deep should I make each peck? That is a tricky question, and no offense, Elijah, I am not going to answer that question because if you break your tap, it's not going to be my fault. That said, I would highly recommend, depending on who you bought the tap from, who the manufacturer is, possibly reaching out to the manufacturer. Now, if it is a blind hole, and you are using an up flute spiral tap, keep in mind, you should be able to go for it. So again, from what I see, a 1-inch deep blind, yeah. Haas spiral flute, awesome. I'm assuming coated, 1/4-20. Okay, so if you're using a 1/4-20 up flute tap, I mean, there should be no problems with being able to go for it. I would also be curious as, oh, you said it was 304, but you could possibly roll form it as 2. Guys, it's been a few years. If you're going to hassle me about roll forming 304 versus 303, feel free to do so in chat. I'd love to see it. But I would tell you, yeah, at the end of the day, 1/4-20, you're going to go 625 deep, which is not even 3 times diameter deep. I would send it. That's just me. I think by pecking it, you're going to cause more problems than you're trying to actually relate to. Awesome. I see more people jumping in here, guys. At any time, if you have any questions, feel free to throw them in chat. 1-inch deep. Well, I'm not telling you that this is what I would do, but if you did do tapping inside of Fusion, give me a sec here. Oh, I don't want to edit my tool. I want to select a different tool. Good old-fashioned tap. Where is she at? Quarter 20. And if we were to say, where is it here? Tapping with chip break, by default, this is what Fusion is calculating based on all of the calculations. So this is saying a pecking depth of blank 0625, which seems very small to me. And then once it gets 625 deep, then it will do a full retract. So again, this is a chip breaking cycle versus a actual peck tapping. So it is pecking, it's just not doing a full retract every time. So again, this is something that would possibly work, is you could go down a certain amount and retract or reverse just a hair, go in just to break the chips off, right? But I'm kind of curious. I would tell you to go for it. That's just me though. Any other questions outside of that? I see a lot more people have jumped into chat. If you guys have questions at any time, Stuart is correct. You are basically in the game of utilizing the inertia and the momentum as well as the torque curve of your machine, which is always a good conversation that I love to have to people is, you know, hey, when I try to use this tap, it doesn't work and it breaks the tap. And then you find out you're not in the torque curve or you're stalling the spindle, and all of a sudden you need to crank up the actual RPMs to get into the torque curve. It's a good time, let me tell you. You need the dark side. Is that what we are over here at jitcadcam, is the dark side? Cool. Any other questions outside of that, guys? Feel free to ask anything and everything. We are here to support you guys. Again, thanks to all of our current customers that are purchasing support packages through us as well. If you don't have support or Fusion through us, feel free to reach out. We can obviously get you guys set up. This usually covers a lot of things like machine sim builds and post-processor edits, as well as some custom training rolled into one. But if you feel that you're an expert and you only want to come in here every once in a while and hassle good old Fusion Phil, you could also buy him a beer or buy him a steak to make his day much better. Now, for any of you out there that are in the Oklahoma area, and as I'm starting to hear, we have 4 other HOS facilities lined up across the Midwest that are also going to be hosting these trainings over the next few months. But your time is now to get registered in Oklahoma. Come down. You can meet yours truly. We're doing a 3-day class. This is a beginner class. You could come from one day. You could come for all days. The good news is I would challenge anybody and everybody that you will, of course, learn something new each day, regardless of how long you've been in the software. I will also say on my end, every time we do these courses, I learn something new one of those days. So Stuart's asking, did we talk about slope to lay off the walls and top? We did talk about slope a little bit there, Stuart, but what we did is we were utilizing slope to generate the idea of not cutting on the tip of the ball end mill, because we utilized a ball end mill that usually only has 1 or 2 flutes to center versus the full 3 or 4, right? But Stuart, if you got more questions than that, feel free to throw them in chat. Obviously, everybody loves it when you're here with all the questions. Elijah, how do you organize soft jaws? Do you copy the jaws and part first, then bring in the part to the new jaw file? Keep making a mess of this. So what I do personally, let me go ahead and actually, pretty sure I just built a brand new version of the Kurt Vise. Maybe. We're going to find out here today. So I don't think I have soft jaws on here. I don't. And let's just check to see if my parameters are set up. They are, which means, oh, I have my parallels, but I don't have my stock in here. I never saved things. That's all right. So what we're going to do is we're going to lie. We're going to utilize these parallels as if they are our soft jaws real quick, guys. So we are going to say they are 2 inches tall. And then let's just say we are using a 1 inch thick parallel. So as you guys can see, these big blocks that normally are my parallel for my part are just taking the place of what I need to be able to create and machine my soft jaws. So what I personally do, Stuart, is if I am in the market to create a multi-setup part, what I would do is I would start by getting my part file, of course, uploaded into Fusion. Let me see what I have here. Let's use the shock bracket. This will work pretty good. So normally most people try to open up the default file and then they start bringing stuff in and doing all the kinds of craziness. The issue with this is that your body is relying in the very main component, which means this is going to leave the body at the top of your assembly, causing problems later. So what tends to work better is to start a brand new file. And what I'm going to do is I'm going to save this. And this is going to be shock bracket manufacturing, right? Or machining, whatever you guys want to call it at the end of the day. Now that I have a brand new fresh file ready to go, this is where I'm either going to drag and drop in my part, or I can right click insert. Now, the luxury of this, when you guys start to deal with customers with a lot of rev changes and things like that, as you can see is one, I'm linking back to the original customer part, which means unless I break this link, I cannot screw with this model, right? But if my customer sends me a rev change, I can override the original and bring it through my system. So now I have my part. This is where I could go back to wherever my Kurt Weiss resides or whatever you're going to utilize. We can bring that guy in. And now what I'm going to do is I'm going to go ahead and break that link, right? So as you guys can see now, I have my setup one vise. And if I wanted to do a second one of these, I could right click copy. And then I'm going to go up to the top and I'm going to go ahead and paste new. Now, the element here of paste new is so that we can move one without affecting the other or cut one without damaging the other. So again, there's my paste new. And now presumably we're going to rotate this 180 degrees and it's going to basically move up. Now, I am just roughly placing everything right now so that you guys can get that visualization in, because this is now, of course, set up 2. And then I do still have my part in here where I would move this, or again, you're going to have to build this out for your guys' case. This is where now I could do my cuts, my extrudes, my combines to cut the jaws using one from the other, right? So again, this is the great thing about Fusion 360 is once you build out this workflow and get everything set up, we can do anything and everything that we need to actually generate and update our part files, change even in this case, our parallel sizes, our parallel thicknesses. What you're seeing me do here is I'm going to each individual setup right now. Setup 1, this guy is going to be, let's say 1 inch. We're 6 inches long. And we're not going to use the parallel height. We're going to go ahead and just trying to think off the top of my head. Yep. So we're going to do this a little bit different. So we're going to say this is actually 1 by 1. And as you guys can see, we actually need to be 1 by 2. While on my second set of parallels, I'm going to go ahead and make these 2 by, let's say 3, right? So as you're seeing me do here, I'm manipulating each vise independent of one another. And then this is where I would have to do, you know, my combine, my cuts, my extrudes, all of that fun stuff, right? So again, I am just going to speed up the process here so we don't bore everybody to death. But let's just say my part is going to sit here, flip it back the other way, bring it up just a hair. And then I am going to have to place my second vise in here. Again, this guy's going to align something like this. And as you guys are seeing, my part now sits basically where I'm going to hold it in setup 1 and setup 2. Yeah, that's just the nature of the beast, man. We're looking at the top assembly. So as you guys can see, if I still went to just one of my vices, my entire timeline is shrank down now. But that is when I brought in this Kurt Weiss, we had to convert all the bodies into components, all of this stuff, yada, yada, yada. So again, what I'm trying to do here is, as you guys can see, I now have two vices. I have a vice for setup 1. I have a vice for setup 2. Now, building these vices is something that you guys are, of course, going to have to do. I would recommend building one Kurt vice that has stock and parallels, another Kurt vice with soft jaws, or starting to get into the world of configurations. We're getting deep in the weeds, right? But the idea is still the same, right? So now I could do my combine. We're going to capture this position technically. My target body is this guy here. My tool body is this one. We're going to do a cut. And then we're going to repeat that one more time here with this guy, another cut. If I get my part out the way, as you guys can see, I now have these jaws here. I'm going to go ahead and delete those holes. And just like that, I now have setup 1, setup 2, and my part. Yes, we would bring the jaws in and do all this other crap, right? So in the manufacturer side of things now, this is the cool thing that we could start to work with is one, we could bring in our CAM data from that part if you had setups. In my case, I do. I don't want to do this. If I was working on a tombstone, then I would start to bring things through automatically. So we're going to go ahead and say cancel. But if I create my setup, again, what is my part to be manufactured? In this case, here's my shock bracket. My fixture is this entire setup 1. I need to set my Z-axis, of course, Z up. And just like that, there's setup 1. I do another setup. Again, I pick my Z-axis. We're actually going to flip Z-axis the other way. My model is going to be the shock bracket. My fixture this time is now my setup 2 fixture. And just like that, you can see how I can flip from one to the other by activating said setup. So as you guys can see here is into my second setup, we're utilizing things like from preceding material, continue rest machining. So in my first setup, let's hit this thing with template. What do we have for toolpaths in here? Nothing but a bad time. Oh, that's right. This is a junk template. So let's go to another template here. You used to have a lot of templates. Where did they all go? That is a good question. 3-axis mill rough finish. There we go. So just like that, we just faced off our part. I'm now machining around the outside, roughing it out. Lastly, we're coming back and we're doing some cleanup work with a contour toolpath. Now keep in mind, in my toolpaths, I don't have things like the fixture detection working to my advantage, things like that, right? So again, that is something that we want to make sure that you have set up and that you're utilizing so that we're not hitting our vice jaws. So as you can see, upon regeneration, one more time, we're now avoiding. And for those of you wondering about my toolpaths, I'm going to go ahead and turn my linking moves back on. But just like that, with fixture avoidance, I don't have to worry about hitting the fixture. Now, this is a key element here, right? Like this is the fun of like all these updates that everybody on Facebook has been complaining about is like, why did they change the heights tab? Why did they do this? Why did they do that? If I'm the end user of the software, I love the fact that instead of model bottom, I could actually say fixture top, or I could go off highest of, lowest of. So again, fixture top, I would like to stay at a minimum 20 above that. And what you're going to see is I'm now trimming my blue lines, right? And I want to make this clear to everybody. I'm trimming how deep those blue lines go in my part, right? I have fixture detection, meaning don't machine the fixture, but now I also have don't go lower than the fixture. Yep, Elijah, you get it, man. 100% is now I'm never going to have an issue where I will hit my jaws, right? But this is the fun of this, is like, as you guys can see, is very quickly, again, I do have to regenerate this from the copy and paste in. Again, now that secondary regeneration, Autodesk, I know you guys watch my content, fix that. When I bring in my template, why doesn't it know my fixture is there until I regenerate it a second time, right? But as you're seeing, it's the same thing all over again, right? Is the ability to quickly come in, make those changes, make those edits. Now I jump over to my second setup, and yes, I know this big old lug of material shouldn't be there, but as you guys can see, this is the fun, and this is where doing the design side makes the CAM side 10 times easier. Because at the end of the day, if you actually built out, and this is where I always challenge people, You could use configurations to set up multiple vices and multiple orientations all ready to go off of one stock box, right? That is going to be the advantage to anybody and everybody to be able to say, we're going to go from a dovetail, you know, I need to machine the dovetail stock in a Kurt vise. Then I need to put it in a 5-axis dovetail vise. Then I need to go back to a Kurt vise with soft jaws. We could have already had that all set up, right? Any questions outside of that? Again, all I'm doing here, going in and adjusting my heights, right? So as you guys can see, let's go ahead and flip back over, now edit our toolpath, is I don't want to use model bottom. I would like to make sure I'm aware of the highest of the fixture top and ignore everything else. And again, just like that, we're having two sets of a clearance here, right? So first and foremost, I did not tell my heights tab to go above the fixture top by any additional offset, right? Now, your fixture itself has a clearance by default. And that's the cool thing that you see here is the fixture itself from the global settings, which is my setup, is clearancing everything by about 200. That's why we're getting that stepping down around the outside. And you could override this. This is, again, this is the stuff that I love at the end of the day is like, let's say, for example, is I'm living dangerous. I know I can get 150 thou at least closer to that actual fixture, right? So again, is based on radial or axial. Actually, let's do it. Let's change things up. Let's say radial, we're going to stay at 0, which means it's still going to be at almost 200. But axial, I'm going to bring us down so that we're within 50 over here on the left, right? So again, as you guys can see, now we are getting closer down in Z while only still maintaining whatever our X and Y direction is. Yep. So again, that's what we're seeing right now. So you guys know is, as you guys can see here, my avoid machine surface fixture, the default settings in this case are coming from what I like to say is global. It's the master cam side of me, right? Your global or your world coordinates. Again, when we actually picked our fixture, we could have set this actually to something much closer to what we want, right? Realistically, let's say I'm always happy with 100. I could easily come in, set both of these to 100, save it as a user default, and then from there, in a case-by-case scenario, add to or move closer to or further away at the toolpath level, right? So again, this is the cool thing about being able to override at any time. It's the same as when we use model, right? So I was just talking about model on the die is at one point in my toolpath, I believe it was that corner toolpath, right? Although in my setup, the model in this case is the die, but for a specific toolpath, I needed to do something in exception to, which is add that surface that extended my blue lines again, so that I'm just not starting on my part. This is why we host this type of stuff. We love to show you guys the cool different features, the way to set things up, the way to work through this all a little bit differently. I am now realizing that my big old fat head is in front of this menu when I'm talking. But again, the idea is still the same, right? You have your setup, which is always going to be the finished goods or the overall world global settings that you want defaulted in your toolpaths, with the ability to go in and add additional things outside of that, right? So if I added fixture offsetting, again, I don't have a fixture in this part, so it never actually recognizes that there needs to be a fixture, right? So with that, how's that feeling? What are you guys thinking? I see the chat has started to go wild here for a moment. Elijah, does that give you a little better setup and scenario? As you can see is, again, one thing you will want to turn on for any of you out there is down here at the bottom in the center of my screen, there's this lovely little yin yang circular arrow sign. You want to go ahead and turn on all your synchronizations. This will allow you, as you guys saw, when I go to my different setups, it automatically kicks on and kicks off things. So if you're a guy in a shop that has a 2-axis lathe, and you're going to do a lathe part, then you're going to move it to the mill, and you're going to do this, and you have, again, you watched my lovely video on the container method for the lathe. You can quickly jump these setups, and as you're seeing, flip your part around, bring your stock through everything and anything. When am I coming to SoCal? Elijah, good news for you. Heidi, our new sales rep, is actually up in Orange County. However, we are trying to arrange something with one of our dealers down in the San Diego area, as well, quite a few up in the Orange County area. So if you don't want to model in your vise/fixtures and you are using a dovetail jaws, I'd like the bottom height as stock bottom plus 0.2 for a dovetail height. So Deep Thinker, you could actually go further than that. Again, here's a perfect example, right? So what I need to do in this case is, as you guys are going to see, I'm going to quickly draw up some stock with a good old-fashioned set of rectangles. We're going to put a 45 down here. He's using 200, so let's get 200 down here at the bottom. Not 2 inches, 0.2. There we go. And then from that, let's say, for example, our stock material right now is going to be 2 inches tall. And then we are going to make it actually 4 inches wide, but we're going to divide that by 2, and you guys will see why. And then, of course, we have our dovetail, which let's go 3 divided by 2. And now I'm going to extrude this out. So again, let's just say, for example, this is my material. Lastly, we're going to use a mirror this guy across center line. So that's my dovetail stock, right? So the cool thing about this is when we go into our parameters, not our appearances, let's go into our parameters. And now this is where the fun begins. So right here, line dimension, yada, 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 is our dovetail height. So if I made a user parameter, dovetail H, and then this is going to be, we're going to change it to 150 real quick so you guys can see this, but I can plug that in down here at the bottom. Now, all I did was made it easy to understand. That's all I'm going for here, right? So with that being said, though, is this dovetail H right now can be pulled from my cam side now. So again, this is the value of setting up something as simple as a template for stock with a dovetail, because presumably in the manufacturer workspace, I would first and foremost, of course, need some tool paths to actually go in and create our dovetail kind of setup, right? So again, as you guys are seeing me do here, there's my XYZ. Maybe you're, again, 3D adaptive clearing. I want to give you guys about as real world scenario as you can, right? So again, now we're machining, you know, we're roughing this out. You do your 2D contour to cut your dovetails. But if I have a second setup in place now, Z-axis back the other way, right? Now, when it comes to machining, let's say, for example, I'm going to do adaptive clearing. In my heights tab, I could go model bottom still, right? Or this is actually going to be your stock, so it would be stock bottom. But then I could say I want to stay above that by utilizing what? None other than good old-fashioned dovetail H that we put in before, right? So, as you guys can see, by adding dovetail H, it has automatically bumped us up to whatever that bottom distance is. So Stuart, let me, or actually not Stuart, Deep Thinker, let me know how you feel about that. Because again, what I've done is I've used a parameter on one side to force that parameter into this side and be able to create, do not go further down than blank, right? Orange County, you're going to be there. Awesome. Elijah, shoot us an email at the info email address down below. Let's get your information so that we can make sure you stay up to date on that. Oh, man. Old Ian Mickey 40s. There we go. There it is. Thank you, Elijah. I appreciate the beers and steak that I am going to consume very heavily over the weekend. Other questions outside of that? Stuart, what about leads on 3D Toolpath, Smooth, etc.? I would need some examples, Stuart, if you could send something over, or if you want, we could jump into another meeting outside of that. Sorry, checking my ticket system real quick to make sure we don't have anything going through. So it's just our email address down low in the description of this video. It's info@jitcadcam.com. So Heidi is actually your guys' sales rep out there in Orange County, and she'll take care of you guys for sure. Ah, you want to know more about the different settings. Okay. Yep, we can do that. So again, let's see what toolpaths we have to work with. Beautiful. Good old-fashioned steep and shallow. So when it comes to your actual transition, you're talking your lead in, lead out, right? Not your transition types. What am I thinking? At a job shop, mostly round stock, the dovetail spacing always changes. The material length changes by the person cutting the saw. So a fixed parameter usually doesn't work for me. So Deep Thinker, let me show you this real quick. So the idea isn't for you to have fixed parameters. The idea is for you to be able to manipulate the system to your advantage, right? So as you can see here is I could make, you know, stock height. Again, let's say it's going to be 3 inches now, and I could plug that in to wherever I have my stock height, right? So again, stock height. Again, we could say now stock W. Stock width is going to be 4. Actually, let's go back to 3. We're going to break the system today. So again, we have that stock W divided by 2. And then lastly, we need one more for stock length. And let's just say we're going to go to a 5-inch length. So again, as you're seeing me do here is I'm going through and plugging in my information so that we could auto update. I actually screwed that one up. Let me go back here real quick. I got to remember what dimension 6 was, and now I do. It's actually the dovetail width. So let's set that back to 2.5 in this case. I am wrong. So it's this guy right here, I believe. There we go. There is my dovetail width. Now we should be able to set up, again, stock length. There we go. Now we have a length control. We may have to go back and edit my sketch because I royally beat this thing up here. Yep, so there's our width. There we go. And then this is going to be stock width divide by 2. And we're going to throw this in brackets. And simply enough, we are going to always make this minus, let's say 3/8 of an inch each time, right? So now no matter what our width goes to, our dovetail width is going to change as well. But as you can see, the whole idea is for you to be able to quickly come in and say, oh, you know what? He cut me a stock piece that's actually 5 by 4 by 10, right? And just like that, I've quickly updated my stock size. And then when I go back to the manufacturer side of things, technically, everything is still automatically being generated to include, as you're seeing now in real time, my roughing cycle and everything has come through right off the rip, right? So again, this is, again, Deep Thinker. In your case, you could just model up a piece of round stock, kind of like I did before. Is you could just throw a circle on here. Again, we could create, you know, if you wanted to just do a simple line, your dovetail angle, like so. And then because we are going to end up just patterning this across or mirroring it, makes my life much easier. Same exact concept, right? So again, when I extrude this guy, there's my piece of stock. Again, mirrored across center. Now I have a piece of round stock with a dovetail. So again, I've beat the entire system by just preparatory creating my own solid model that could have the dovetail cut ready to go, as well as where your work offsets are. And even if you have an alignment pin or something could bend in here, right? So back to Stuart's question about the linking and leads moves. Let's get back over to that die example. So what he's referring to is based on your transition types. Again, the thing is there's a lot of different settings here. Now, how they're going to interact with your part, of course, the easiest way I tell most people is if you duplicate out your toolpath, and let's just make each one individually different, right? So we have smooth, their shortest path. Again, we're going to go in and we're going to set this one to straight line. Now, this is where you're going to get a little bit of a difference in variances on this specific surface. And that's because we are transitioning basically in the same consistent direction, right? So as you can see, by default, smooth is just looping back and forth. Now, I do have both ways turned on here, so keep that in mind. So the idea is smoothly coming off the part and transitioning in what would be a 3D helix, right? So we are moving in X, Y, and Z simultaneous to get down to our next location. Jumping into our next setting, again, what we have done is we have now set this to shortest path. The problem is it's doing a full retraction, right? So in this case, we may need to change our retraction policy at the end of the day to change out how that is going to transition. This is why I always tell everybody it's like reading a book, right? Top to bottom workflow. Because if we go in and we say shortest path, now with shortest path, you're going to notice is one, it's still trying to force the lead in and lead outs and transition between those two. And that's what you're going to see as we go a little bit further down. Now, again, this third toolpath we have made is called straight line. So or straight line. Yes, straight line, again, is a quick transition from one to the other. So smooth is allowing an arc to happen so that it speeds up. You don't have deacceleration and reacceleration issues on your machine. Now it's just going to be a hard stop, move over, go down to the next one. Same thing would happen is inside the world of no contact. You're seeing once again, it is coming off the part so that it doesn't touch, but it's going back into machine back down that part. Now we could see more of this if we started to look at a few other tool paths. Again, geodesic in this case, as you're seeing, same exact thing. Straight line, smooth, follow surface. There's a lot of different things that you can set and change out to, but it all still comes back to the same as to what your plans, your goals are. Again, this is a perfect example as we're seeing if I get zoomed in here. Let me get the toolpath out of the way. The way we're transitioning, I know somebody had some questions about surface defects, things like that. As you're seeing is my transition, large step over. I am now creating a line versus before when we were doing a vertical lead in, lead out to get off of the part. Me personally, 90% of the time, usually what I'm utilizing has always been smooth. As you can see in the world of smooth, if I could just come off my part and come right back in, again, I don't have a hard stop and a hard pivot or a 90 degrees change real quick. Very rough on a machine, very jerky on a machine. This is what I would prefer. Outside of that, is there any other questions? I see more people coming and going. Stuart, so yes, we talked about that a little bit earlier. I think I didn't have my screen share turned on like an idiot. But as you guys can see is cusp height rather than step down. Inside of anywhere inside these toolpaths, keep in mind, whether it's a step over toolpath or a step down does determine whether or not it's for floors versus walls. But you do have what's called a cusp height inside of here, right? So again, there's a lot of really good calculators out there for surface finish. Now, you could write out a pretty crazy expression or equation based on surface finish to auto find cusp height, but 100% controllable at the end of the day from either or. Again, a few other things to keep in mind. You do have the ability to change. Again, all of these toolpaths work fundamentally the same when we talk about getting into things like geometry selection and your boundaries. But as you progress into your passes tab, every toolpath has a different way to define things or how it's going to set. Stuart, I hope that answers your question. Anybody else have any other questions outside of that? Give you guys a few seconds to throw some stuff in there as you guys may have. Give me a quick second here. Trying to remember what I was doing with my life. There we go. Boom. Any other questions? They jump back over here. Just want to make sure there was nothing in my support ticket area. So technically, Stuart, you are correct 100%. Again, you're not necessarily one versus the other, because at the end of the day is if you are in here utilizing one over the other, the idea, and this is where Stuart's thinking is coming from, is there is a cusp height based on a tool radius that determines a surface finish, right? So if you're working backwards from a 125 finish and it says with a 1/2 inch ball that you can get away with a, 11 thou cusp height, right? As you're going to notice, it's going to adjust my step over to a really crazy number, but that's the idea, because at the end of the day, that's probably not the best example. Let's say my cusp height allowance is up to 7 thou, right? As you're seeing, that's calling for an 83 thou step over. If I was technically originally running this part at a 60 step over, I'm probably overkilling what I can be getting away with, right? So you could get faster cycle times by all means by adjusting one versus the other one. It has to use step only if it cannot work it out. No, so Stuart, one thing I think you're thinking too far into this. So if we edit the expressions here, is one is basically being calculated off the other. So as you can see, distance to cusp, tool corner radius, step over, math, pi divided by 4. So when you type in your step over, it is automatically calculating your cusp height for you. Or vice versa, when you type in a cusp height, it is then calculating the step over for you. So at the end of the day, it's not one or the other. They're actually both the same number. Now, keep in mind, because we are doing step over, your cusp height might be different than step down. So you cannot vary them. No, so it's not a one or the other. Again, they're both the same. You would need to use something like a steep and shallow toolpath that has the ability to attempt steep passes with a completely different step down than a shallow pass that has a completely different step over, if that makes sense. Now, if we go back and we look at something else here, again, not a good situation, but if I did a 3D contour, now I do have in certain toolpaths the ability to do what's called machine shallow areas, which would allow you to do different step downs based on adding additional passes when a tool exceeds certain variables, right? So again, the idea that if you were using 3D contour and you were trying to do this fillet at the top, I need to add more passes at the shallow region. And that's how I could do that, right? But to me personally, as I think a lot of you have seen, the value is in the world of steep and shallow, I can get away with actually generating a completely different set of parameters based on a shallow region. Now, if you were doing stuff, again, we start to dive deeper and deeper always into the different weird commodities and things you get into. As you can see, it could be from tip of tool. We could say on surface. Again, you have the ability to change your step over calculations on this actual part specifically. I mean, I wouldn't say it's inefficient. The application of geodesic is based on a case-by-case scenario, because what you get in geodesic is, for example, is I can actually control, one, what type of pass I have, scallop versus blend, but then I can control how is it being driven to create said profile, right? So if I have a customer that's really particular about what that surface finish is going to look like, for example, circle at center, what you're going to notice is it's now going to 3D surface everything, but it's all going to circulate outwards from there, right? Not the best of case scenarios, but the idea is I'm no longer confined by like, this is the way it's going to do it. I can control the exact way it's going to do that profile versus, again, Steep and shallow, my options are parallel, which are only going to run in a straight line direction, or scallop only. That scallop is only going to do the same, right? So again, as if we go back and we go back from parallel to scallop, again, I can't really give this a specific path to follow to create a texture or a profile, if that makes sense. So the thing is, Stuart, is based on rest machining and your stock to leave settings. All of that is going to play a factor into additional passes, right? So again, as you start to roll things up, and I'm just showing you this as an example, let's get my leads out of here, or my linking moves. Again, this is a scallop toolpath, right? It is only going to start based on the outside perimeter and work its way inwards. So that is the geometric pattern that you're going to get. Geodesic, on the other hand, you have a lot more control in that boundary and how you're going to control it, right? Now, again, we can play that game back and forth as much as possible, but this is where, again, we could do things like in the world of rest machining, ignore stock less than certain scenarios to make sure that you're not double machining or over machining any of those areas. Awesome. Any other questions outside of that? I'd be happy to answer anything and everything that people have going on. Stuart's hit me hard with all the questions. Feel free to keep them coming, Stuart. I don't want to cut you off like that, but I understand your concern that you could get to a point where you should have done less step overs at the top versus more step overs at the bottom. But it still goes back to that starting to get down into the refined workflow of like, this specific surface needs this, while this specific surface needs something else. It's not going to be a one fits all. Steep and shallow does a really good job of that. But again, as we've seen on a part like this, scallop works amazing to follow this fillet, but it sucks when you get to the ends, right? Like this is where, again, in my world, like I would love to see Autodesk allow you to combine toolpaths. Feature CAM does something like that, where if you start to use the same toolpath across a couple of different strategies, you can merge all those together, right? So again, in my 2 cents, in the way I would look at this is like, I like corner for my rest machining. I like geodesic for the floor, but then I like, you know, maybe steep and shallow for strictly the walls, but then I still have blend in effect. So like, why can't I take these three and start to merge all of these together? And like you're saying is like, yes, we're remachining a couple of areas here, possibly. So again, just on your case on this part too, keep in mind is I'm using a very large end mill, the 1/2-inch ball here. And then lastly, I am doing rest machining with a 1/4-inch ball to clean up what's left in those inside corners. But I can understand your mindset. Again, merging the toolpath together would be nice. Having it auto trim in segments that it doesn't need, things like that. Now, again, I have rest machining turned on, detection limits, again, still all able to be utilized as well. Cool. Any other questions outside of that, guys? Stuart, I know you were asking before about the free trainings that we're putting on. I think what we're going to do is we might put together a online webinar type based thing and be able to show what we show in those classes. It's kind of hard to do because one, yours truly doesn't really have a very specific outline for these classes. And depending on the speed of the class changes what we show. But again, we might try to do a 4-hour, 4 hours would be rough. Maybe I'll break it out into like 30 to 40 minute segments of the parts we cover, the conversations and the subjects that we do. Issues with rotary. I mean, if you could send me the part file, I'm happy to bring it up. We could take a look at it. Just look at it, right? Give me 1 sec here, guys. Gotta shoot out an email real quick. All right, and we're back. Any other questions outside of that? Well, so that could be a couple of things. So all right, so millions of steps around. So stalling the machine. Okay. Deep Thinker, I feel like you watched one of my videos about simplifying, huh? Works quite well for converting a part back to a round on center. So let's go ahead and get us a round part profile for rotary. So I'm going to go ahead and start closing out some of this stuff for you guys. And let's get back to good old-fashioned one file. All right. So let's do a real quick drawing of a part so that we can apply a rotary toolpath. There we go. And let's go ahead and spin this guy around center. And then with that, let's go ahead and go to manufacture, new setup. We're going to treat this as a mill. X-axis is going to go around this guy. Let's throw this on the end of our part. And of course, we are going to use round stock. There we go. All right. So if we're looking at the rotary, you were using rotary contour. What were you using? Geodesic. Issues with rotary. Rotary, rough, and contour. Okay. So let's go ahead and do our rotary pocket strategy. Around our X-axis, select a tool. Get my favorite tools out here, like a good old-fashioned 1/2-inch end mill, of course. There we go. Now, a couple of things I will point out real quick is when it comes to something like rotary, technically it would look more like this on the right side of our machine. Let's do something here. Okay, there we go. So, as you guys can see, is one, we have our toolpath, but something to keep in mind is when looking at your toolpath, the first couple of things I tell people is turn on tool access, right? So as you guys can see, is there's a million little red lines here, right? And or actually not red lines, but the blue lines is what we're looking at. Now, this is a telltale sign. Is it the machine data starving, or is it the toolpath, or is it the way your machine is possibly set up? Yep, if you showed points, it is covered, but I'm going to show you a few other things too. So as you guys can see, is one is we can turn our lead and links off and even our cutting moves. But the real problem is still going to be is we need to be able to define like where the problem resides. Again, we are going around a cylinder. So let's start by simplifying this. First and foremost, let's go ahead and get rid of step downs, and we are going to just make this much bigger. Let's say 1-inch step downs. Now you can see with a 1-inch step down, this is what we're looking at, is every time you see this blue line, or if we turn on points, every time you're seeing a point on this blue line, what is happening is we are changing an axis, whether it be A axis, X, Y, Z, A, B, all of them, right? They all work the same. So what is going to happen now, and I've seen this on a super old Fadal machine as well, where it ran really slow and it seemed like it was jerky, is when you set your machine up inside of Fusion. I'm going to go ahead and select a machine here. Now I got to think off the top of my head what I have with a axis. I believe this does have an A axis. I need to save my part first, of course. Let's go ahead and get this saved here for you guys. And we're going to throw this in the good old-fashioned YouTube. Where is it? Free Support Friday 2025. Can you guys believe we've been doing this as long as we've been doing it? So first and foremost, now that I have my part saved, let's go back and select that machine. And what I am going to show you here is on the machine itself, in my kinematics area, first and foremost, as you're complaining about A30,000, is don't use unlimited. You probably want to use cyclic and then have 0 to 360 degrees, which means it will now do things in 360 degree multiples, making your life 1,000,000 times better. Now, another way you could go about that is, of course, limited. Now, another feature I'm going to have is the ability to go into multi-axis and change from program feed rate to, based on your machine, degrees per minute, inverse time, things of this nature. Now, this is night and day difference if your machine seems to be running just god-awful slow, right? So this is where I would tell you at the end of the day is you want to go ahead and change out based on what your machine is capable of doing, right? Some machines will say feed rate 60. It will handle, you know, changing 60 inches per minute to degrees per minute and things like that. Again, Stuart, as I'm showing you, this is where I would start to point you, and we'll show you an example here. So we have a machine selected. We need to swap out the post processor. Give me a quick sec. We're going to throw this on a Haas post. Actually, we could put it on Fanuc, would make our life super easy as well. Fanuc, there we go. Sure, copy it over. There we go. So if I posted just this one toolpath right here, right? Post process. And as you can see, as we skim down through here, a feed rate of 13 into a feed rate of 40. Now, all of this A motion, X, Y, Z, A's is all of the motion that it's taking. So in order to make one 360 degree rotation, we are starting at A, where is it? A negative 100, and we're rotating around to A 259. So again, as you guys are seeing, from 100 to 259 gets you about 359, which presumably is 360 degrees, right? So with that, now let's go back and make that one subtle change to start with. So again, I edit my machine. Maybe. We go to the multi-axis tab, and let's say we go to degrees per minute or inverse time. Yeah, let's go degrees per minute. So this time when we post this out, what you're going to notice is my feed rate is going to be crazy high because we are now feeding in 2,251 degrees per minute, right? So again, as you're seeing is we have now upped the ante at to which how fast the rotary will spin. We're overriding the rotary. We're not using inches per minute with the controller handling the math. We're calling out a degrees per minute, which again, this might be issue number one, Stuart, that you're having. And this is what I noticed on a very older Fadal machine is the toolpath looked like it was jerky and it was just running so slow. And no matter how many inches per minute I gave it, it didn't seem like it picked up speed until we swapped it out to degrees per minute. So that would be one thing I would have you look at. Now, again, is a machine can only physically move so fast. That is another thing to take into account. However, in this case, on this particular toolpath, if I'm running 40 inches per minute and we're spinning that rotary, we should be able to do that no problem, even on an older Haas machine. So again, usually the degrees per minute will help you out. A few other things, again, your tolerancing makes a pretty big difference here. So if I go back to 4/10 tolerance, as you guys can see, I've increased the number of points. Now, this is a tricky one because leading into the world of 3-axis, usually you can up your tolerance and it will help calculate faster toolpaths. You won't notice a difference on your part. Now, when we talk about 4 and 5-axis, as funny as it is, sometimes you actually need more points to create a smoother, better operating toolpath, right? Because if you think about it, there's basically a fan. So like old school Chinese hand fan type of scenario is the distance that we're having to fan from point to point. You might have to be jumping such a long distance and swinging a super far length, right? So as you guys can see is something as simple as upping the amount of tolerance or adding something in like smoothing. So what I'm going to do is I'm actually going to put my tolerance back to the other that I had so that we can quickly compare that if you're trying to move from point to point and you're in inches per minute on your machine and it looks like it's just like jerking real hard because it's moving here to there, then spinning, then moving here to there, then spinning versus a very smooth point-to-point operation. Now, I'll tell you at the end of the day, based on that information, Stuart, I would say that I would look at the fact that your machine needs to be using degrees per minute, number one. I would almost attribute that specific problem to it. Because even though there's a lot of points here, let's say this is 100 points. We could whip around 100 points in a full 3-axis surfacing toolpath with no issues, right? And I assume it's looking very smooth if we had 1,000,000 points because we were doing a mold cavity as we talked about earlier, right? Because if we go back to this mold cavity and we look at the millions of points on this guy, so let's get the tool axis turned off. There's a lot of points in here and you're transitioning quite a bit. And again, with linear lines, you're even feeding super fast and then hitting very quick changes. It probably looks fine, right? If your 3D surfacing is fine, but your rotary looks like crap, I would 100% attribute it to the fact that your machine is in the wrong feed rate when it comes to utilizing your A-axis. Now, you could adjust this even more. Obviously, we could go back. We could add smoothing into this. Again, turning on smoothing, setting your evenly spaced points. So again, smoothing with evenly spaced points isn't going to necessarily reduce points. It's going to come in and it's going to actually add more points in. And again, now we've gotten a completely different result. Tolerance is up, smoothing brings us back down. And then as you're seeing is we've actually gone from a 4/10 tolerance to 4 thou with 20 thou spacing has created even more points. So again, it's usually not a data starvation. What I think you're honestly facing, especially if you have high speed machining, again, the problem is still coming back to the machine is not getting the right feed rate to start with, if that makes any sense. So how I would start is, again, every machine is different. I'm just going to show you where it is to change it. And as you can see, again, under multi-axis, we could set it to whatever we need. Again, inverse time, degrees per minute, things like that, right? So again, degrees per minute combination, I believe will actually outspit. It's been a minute since I've had to go down this rabbit hole. But if you had a wrapped tool path where you have straight line segments, it will stay straight line, give you a normal feed rate, then transition into a degrees per minute, then back and forth as well, versus consistently staying in degrees per minute. You also use the offset tool, flat bottom tool. So are you referring to, I'm going to need a little bit more info than what you've given me there. But again, this is just where I'm taking. So Stuart, what I would highly recommend, again, this is just where you're starting to get deep into the weeds with some weird commodities. How old is your post processor? When was it last updated? What version is it? Like, I would tell you if you're running a Haas machine, just go grab the latest Haas post and never look back. It's probably going to work out very well for you at the end of the day. Awesome. Any other questions outside of that, guys? And gals, I should say. Anybody and everybody out there? So Deep Thinker, I do see your question there. There is something coming out. I shouldn't say there's something. There's something that has been thought of in the background to kind of remedy that whole scenario. Move the tool offset to center in Y. Tool offset center in Y. Oh, you're okay. I get what you're saying. It's been a hot minute since I've had to go in and deal with rotary, but I get what you're saying. not utilizing the center of the tool, but you're leading the tool, right? Where is it here? My brain is just not working. Awesome. Any other questions outside of that from anybody and everybody out there? If not, I'm going to hit you guys with the normal. It's not what you know, it's who you know. You guys all know yours truly, Fusion Phil, out here at jitcadcam. And I see you, Stuart. It looks like it's missing on mine. Stuart, if you're on the insider version or if you have preview features turned on, we do not mess with that live on live stream. You're happy to shoot us an email and we'll take a look at what you got going on yours. But with that, again, it's not what you know, it's who you know. You guys all know Fusion Phil over here at jitcadcam. If you guys found something useful today, learned something new, or maybe just want to give a little extra to help support this channel, you can buy us a steak or buy us a beer at our website with the link down below. You can also move your Autodesk software over to us if you're in North America. As well, we offer services or service plans, support packages, as well as custom online training and even post-processor development. Now, if you're in the Oklahoma area, feel free to reach out to us. We're happy to get you guys into one of our free training sessions and get you all up to speed. So with that, I don't see any other questions coming in. I want to leave you guys to it with another outstanding week. Great to have you guys all here. Brian, great to see you guys out in chat, but that's it. We've hit 2 hours. Again, I'm winded. I think my voice is gone. I'm done. I'm out. Maybe I need another 3-day weekend. Have a good one, everybody. See you guys back here on Monday for Modeling Monday.